Welcome to the Explainer. Today, we're diving into a really fundamental concept in programming, static versus dynamic binding. And we're going to get to the bottom of a super important question: which one of these actually makes our software more reliable?
So to wrap our heads around this, let's think about it with an analogy. Picture yourself building something. Would you rather have a super detailed, unchangeable blueprint before you even pick up a tool? Or would you prefer a versatile kit of parts that you can kind of adapt and figure out as you go? That question, that's the heart of what we're talking about today.
Here's the game plan. First, we'll nail down what binding even means. Then, we'll introduce our two big players: static binding, who's like a meticulous planner, and dynamic binding, our quick-thinking improviser. After that, we'll throw them into a head-to-head showdown on reliability. And finally, we'll break down the ultimate trade-off here: safety versus flexibility. Sound good? Let's jump in.
Okay, so first things first. Before we can compare anything, we've got to understand the core idea that all of this is built on: binding.
In the simplest terms, binding is just making a connection, an association. Think of it like putting a label on a box. We're taking an attribute, say the data type integer, and we're associating it with an entity, like a variable we call x. But, and this is the most crucial part for our discussion, the real question is, when does that label get stuck on the box? That moment in time is what we call the binding time.
And as you can see, this binding could happen all over the place. Some of these decisions get made way back when the language is being designed, like deciding the plus symbol means addition. Others happen when you compile your code or when you link it to a library. And this is the big one. Some things get bound only when the program is actually running. This timeline is what splits our world in two.
And that brings us to our two big ideas. Any binding that happens before the program executes, that's static binding. Any binding that happens during the program's execution, well, that's dynamic binding. Before versus during. That's really all it is. Let's dig into that first one.
All right, let's meet our first contender: static binding, who I like to call the planner. This is the blueprint approach, where every last detail is figured out in advance.
Yep, just like a detailed architectural plan, static binding locks everything down ahead of time. The compiler knows exactly what type every variable is, precisely how much memory it's going to need, and exactly what you can and can't do with it. There are no surprises later because all the rules have already been checked and enforced before anyone even hits run.
And here's the money quote that explains why this is so powerful. It says that checking for all these potential mistakes at compile time, which is what static binding is all about, is a very good thing. Why? Because doing that same checking while the program is running is, and I quote, expensive. And expensive doesn't just mean money. It means it costs time, it costs processing power, and it can make your program feel sluggish.
So, to sum up the planner's whole deal, the huge win is safety and speed. You catch errors super early, which leads to a faster, more predictable program. You know exactly what you're going to get. But what's the catch? Well, it's rigid. It's not flexible at all. If you want to change something, you got to go all the way back to the drawing board, change the blueprint, and recompile the whole thing. It's not great at thinking on its feet.
Okay, so now let's flip the coin and look at the other side: dynamic binding. This is our improviser, the flexible kit of parts.
The improviser's motto is basically, why decide now what I can figure out later? Dynamic binding puts off all those big decisions about data types, about memory, about what function to call until the absolute last second when the program is already up and running. It basically figures things out as it goes, adapting to whatever's happening in that exact moment.
Now, you might be thinking this sounds a little chaotic, maybe even risky. But dynamic binding is what makes some of the most powerful features in modern programming possible. It's the magic behind object-oriented programming, letting different objects respond to the same command in their own unique way. It's what allows data structures, like lists or arrays, to grow or shrink as you need them to. And it's really the heart and soul of most scripting languages, giving them that adaptability they're famous for.
So if you take away just one thing about dynamic binding, let it be this word right here: flexibility. The power to adapt, to change, to be versatile, that is its absolute superpower.
Okay, the stage is set. We've met the planner, who's all about safety and efficiency, and the improviser, who's all about flexibility. It's time for the main event. Which of these approaches is more reliable?
First, let's just make sure we're all on the same page. What do we even mean when we say a program is reliable? Well, our source defines it pretty clearly. It means the program does exactly what it's supposed to do according to its design under all conditions. No surprises, no weird crashes, no unexpected behavior.
It just works every single time.
And this table just lays it all out plain and simple. Look at the key difference. With static binding, errors get caught early on, at compile time. That means the developer finds them before the program ever gets to a user. With dynamic binding, errors are found late, at runtime. And that means they can pop up and surprise the user while they're in the middle of doing something important. That's a huge difference.
So, drumroll please, based on everything we've seen, the answer to our big question is pretty clear. When you're talking about pure, rock-solid reliability, static binding is the undisputed champion. Why? Because catching potential problems before they ever have a chance to affect a user is the absolute foundation of building software you can trust.
But wait, just declaring a winner doesn't really tell the whole story, because this isn't a simple case of one being good and the other being bad. What we're really looking at is a classic fundamental trade-off in how we build things. It's safety versus flexibility.
Let's just look at them side by side one last time. Static binding gives you safety. It guarantees things are correct before you even start. This makes your code faster, more optimized, predictable, and stable. Dynamic binding, on the other hand, gives you flexibility. It lets you write more adaptive code. It enables all those powerful features we talked about, and it's just incredibly adaptable.
And this, right here, is the most important takeaway of all. There's no single best choice for everything. The right tool always depends on the job. You know, if you're building a flight control system for an airplane, where failure is not an option, you want the ironclad safety of static binding. But if you're building a dynamic website that needs to constantly adapt to user input, you absolutely need the flexibility of dynamic binding. In fact, most modern languages try to give you a mix of both, the best of both worlds.
So I'll leave you with this final thought to chew on. When you sit down to write some code, what is it that you're really doing? Are you building a bridge where every single measurement has to be precise and locked in from the very beginning to guarantee it's reliable? Or are you sculpting with clay, where you need the freedom to shape and reshape and adapt your creation as you go, valuing that flexibility above all else? The answer to that question tells you everything you need to know.